Hi, everybody. As Luke has mentioned, my name is Sam. I have been with BBD for just under 2 years, I think. But before coming to BBD, I studied for 3 years and worked for 2 years in the animation industry. And I wanted to share a little bit of the things I learned along the way, uh, especially some of the lessons I learned along the way. And so I'll just be doing like a brief cover of things that I've worked with, do a little moment to fangirl about one of my sheroes from the industry, and then do a little quick demo to kind of show you what you can do as a technical artist with coding. So what is a technical artist? Ooh, there we go. So the technical artist was a blanket statement term that we use to just cover all the things that we worked with. That could usually be broken up into two groups. So visual effects, which is pretty self-explanatory, and rigging and tool development. For those who don't know what rigging is, when a 3D modeler has finished creating the character or object and it is ready to be rigged and textured, rigged for the animators and textured, they give it to us. We would then basically put a digital skeleton inside it, tell it which joints the geometry should be following so that we could get the nice shapes, slap some controls on it and give it to the animators so that they could move it and they could come to life, which is pretty cool. It's a very brief overview, but it's still very fun. So in terms of what I've worked with, I've had the amazing opportunity to work with some very skilled and hardworking people on some very awesome projects. The main ones that I would like to raise are movie specials that we made, little short films that would be aired on the BBC on Christmas Day. So namely the animated adaptations of Julia Donaldson's books, The Highway Rat and Stickman, as well as the two short films for Roald Dahl's Revolting Rhymes, where in all of these I worked with rigging and visual effects. While I'm on the topic of the people I worked with and what I did, I'm going to fangirl a little bit on one of my sheroes, Sue, who was my first team lead. She was a fantastic introduction to me for women in tech, as she was just an absolute boss. She had a huge influence on my career and the fact that I even went into coding in the first place. She's a fantastic leader, really smart, really hardworking, and always encouraged our growth within the team. And she has this blog that you can see on the right, which I go to now and then, where she posts her projects that she's working on. Every time I go there, I just get absolutely blown away, because most of the time I don't actually understand what she's doing. I understand the memes though, and it's just really, really fun. One of the first things she told me when I joined the animation industry was that I should learn to code, as it would help my career. And I said, okay, and I started looking into Python scripting as it was relevant to what we were working with at the time. So how does coding actually come into the picture? There are many uses for coding and developing tools in the world of animation, and whether it's to make sure that you import your assets correctly and the same way, or to make sure that your render settings are the same, there's a vast range. But like for most part, what we worked with was speeding up the rigging process by doing some of the automation, not all of it. There are programs like Autodesk Maya that work with MELScript and Python. MELScript is the internal coding language, but there are other programs like Houdini and Blender which have their own languages which allow you to code tools to make things more streamlined or more effective. So automating makes things easier. Yes and no. The age-old answer of it depends really works here as well. You can create the tools, you can take the time to do the research, developing and that, but that can take a lot of time, and you'd probably end up building things from scratch and then having to deal with a lot of bug fixes. So in some cases, what we would do is take existing automated tools, such as the MGear rig here, and build on top of it to meet our specific needs for a project. And in terms of visual effects, sometimes taking the time to automate something to be accurate was a complete waste of time of its own, especially with the visual effects and working in a large production where your time is very limited. Like, you can do the research, you can code and accurately simulate the effects, but that may not necessarily be matching what you need visually and could be cheated in a lot faster way. So to demonstrate, to explain this a little better, I figured I would do a little demo. So let's say I'm working on a project. I've been given a task that I need to create a tool that will generate a 2D water caustics effect on a blue block that kind of looks like a shallow pool, but just like a top view, kind of on the similar to what's on the right there. So I've got my pitch. I know it's very simplistic, but just for explaining a little easier, we've got the pitch. What program are we going to use? For this example, I'll use a program called Krita. For those of you who don't know what it is, it's essentially an open source free Photoshop. Really great. And in the versions 4.0 and up, they added a scripting tool to allow you to make your own plugins, extensions, Dockers, and that with Python. You can also code in C++, but for the sake of keeping things simple, I'm going to just stick with the Python. This tutorial at the bottom here is very useful for being introduced into it if you would like to check it out. It's very helpful and really helped me in getting used to it. So my ambitious self would be like, I could totally accurately make this. There's the maths for it, because the useful thing about the internet is there are the resources, papers, studies, and everything, so that I could do a mathematically accurate generation of the caustics. But if I have a week, it might not go that quickly. And if I'm pressed for time, sometimes it's just really not worth taking the time to go through the maths, especially if I haven't done this level of maths in years. So how do we work around that? I'm going to be using an example from this video tutorial that was based by Adam Phillips. He worked in a 2D animation software called Toon Boom Harmony, and he did a course on their website, on their YouTube channel. On the top right, you can see this is the result of somebody else following his tutorial. And the really, really cool thing about this is there's no water simulation in that shot at all. The fish animations in that is the creator themselves, but the caustics and the lighting effects are complete hacks. The rays from above are a distorted noise map, and the caustics at the bottom is where he's taken a turbulence effect and he's animated it and tweaked it so that it looks like water caustics moving. And so adding a bunch of filters on it, he's managed to make a very convincing water shot. And so we are going to base this off that. Okay, so we have a plan, we have a pitch, we have a program, so let's make the plugin. If I can close there. All right, so if working with Krita, I've opened up a new document. I have filled it with the blue color that's been approved. To briefly cover how I can do this, Krita has a full layer feature where you can do very different ways of filling up your view. One of them is the SE expression, where you can programmatically generate the view that you want. I have went ahead and done a version of the water caustics that I want. You can see there's my code for it. But just say, for the sake of the pitch, let's say I showed this to the director or whatever, and they have approved this and they want that. To make it easier to prevent other people messing it up, what I would do is export this. And so I have, if we look in my patterns, you can see that the exported file is there, as well as the name for it. This is going to be very useful. So we know the tools we can use to generate a convincing pattern, and now we need to figure out a way to apply it, which I will bring to the VS Code. Awesome. So working with Python, this is in the Python resources, the Krita Python Krita resources, where you can put in your own plugins. First thing to do is if you follow the tutorial, you can also see how this works, but you are required to have a desktop file. This is how Krita reads it and realizes, hey, there's a plugin that you want me to import. I'm going to go look for the thing that is named how you've given me, and I'm going to apply it. I'm going to look for the library for this, which is the directory that I've added over here. Very simple init to import my Python file, and then I have my actual code. I'm going to go very briefly. I've kept this as simple as I possibly could. So first things first is we select some of the basics, like the active Krita instance, the document that is active, the root and child nodes, which are the layers that you can see on the right of the program, somewhere over there, and then telling it the selection that we want to do. So we get the file size. Once we've done that, we create an info object. This is essentially a map with the key and value or dictionary. So you add the pattern that we want it to use, because we know that this layer will have the pattern properties, and we select the name of the file that I have exported. And then we're going to create the layer. So we want it to be a pattern layer. We tell it what name we want it to be. We give it the pattern. We give it the parameters that we've set, and we give it the selection size. So this would just import that simple black and white pattern that I showed previously. But what I want to do is make it highlight my blue layer. So I set it to a screen, blending mode. I give it a slightly lower opacity. Just to note, on Krita, when you set the opacity, you can set it over here. It's on a percentage, but in code, it works from 0 to 255. So we set it to about 183, which I think is about 72%. And then we add a child node. Adding the child node is essentially just putting the layer inside that layer list. We do the exact same with an inverted thing. Say I wanted to add shadows to make it a little more convincing. I have my exported version that I got approved. I create the full layer. I give it an overlay blending mode to make it darken the blue. And I add it to the list, changing the opacity to an even lighter thing. And that's essentially the logic for what we're trying to do. To make this a little more cooler, I've made a little pop-up box that will let me know, hey, this successfully worked. And then we want to make it a button that we can push somewhere in the tool list. So that's why we make it an extension. We create a class that extends the extension class. And most of the stuff don't touch because it's pretty standard. But then we create the actions which would then trigger my function that I've created earlier. And then we add it to the Krita extensions list, which is also in the resources. Cool, so lots of code, very confusing, doesn't work. To import, I have now moved the, come on, go away, there we go. To make this a little bigger. So if I wanted to import my plugin, I would go to configure Krita. I would go to the Python plugin manager, and if I scroll down, you'll see there is my plugin that I've created. Fun fact, if you make a mistake, it will gray this out and not let you import it, but it will give you the stack error if you hover over it, which is very nice. I've already imported this. So now, because I told it, hey, I want you to be under tools and scripts, you'll see there is my little button that I've now made. I click it, and it has imported the patterns, set them as I want them to, and let me know that it worked. So if we look on the side here, you can see there's my dark layer, well, there's my highlights layer, there's my darker layer, and this is now available for me as the artist to tweak if I want to make it darker or lighter or whatever. And yes, that is essentially a very quick and easy example of what you can do. Obviously, you can go into much more detail, which would be a lot easier to code in C++. So for the sake of keeping it simple, doing it in Python, but you could then also in future animate this by keying the pattern and adjusting it appropriately. But yeah, that is a very quick example of what you can do. Obviously, depending on what you're working with and depending on what you can do, the options are endless. But I hope you enjoyed. Thank you.